All right, so our sim is done, and that's cool. We can just turn on the ground scar here with the rigids and just kind of eyeball it, make sure that it looks good. I'll keep this highlighted actually, it'll help us see. But yeah, we can see that the pieces are resting on it, as you can see here. And that's what we wanted. So that'll be a nice layer to really make this all come together. So speaking of additional layers, let's do some extra particles. We've got these rigids here, and I like some of these big rigids that fly up into the air. And I think that a large piece of debris that flies that fast and that far into the air would look good having particles trail from it. So let's create a geometry node, and we'll call this one Particle Trail Sim. Particle Trail Sim will be purple, of course. And so we're basically going to get the rigids and then cull out all the ones that we're not interested in. So I'm going to go over to the rigid bodies here. That'll be what we bring in to over here. Get rigids. All right. So let's use a wrangle node to start identifying which pieces to keep, and also actually how many particles to emit from it. So ultimately, I know I'm going to use a density attribute on the pop source node to say how many particles I want to come from it. And that's mostly going to be based off of the speed of the piece. The faster it's moving, the more particles I want to come out of it. The speed is based off of the length of the vector, of the velocity vector rather. Remember always that velocity is direction and speed combined into one, where the length of the vector is how fast it's moving. So if we end up keeping a piece from this battery of tests I'm about to perform, we'll also have the how many particles to actually emit from it. So we can immediately start using this attribute. So if the speed, let's come up with some rules for killing these pieces. And actually, I'm going to get rid of this for now. So if the density is less than, meaning if the speed really, if the speed is less than some speed threshold. If it's less than that, then we'll add it to a group called kill. I'm going to add them to a group because there might be several reasons why we want to kill a piece, but we only need to kill them once. So if you're, and we'll put that speed threshold in a minute. Another reason we might kill it is it just too small? So check for that. Size threshold. Is it less than some size threshold, then same thing. Add it to the list. And finally, kind of like our test from before where we said, hey, should this thing switch over to being collidable in our RBD setup? We're going to say, has it been alive for too many frames? Like, even if it's big enough, even if it's fast enough, if it's just been on for too long, let's just turn it off. Because we only just want like little extra streaks coming out of the main explosion. So is the frame greater than the frame that started plus some buffer amount of frames? So same thing. If that's true, then you get killed. And there you go. Now that group alone does not kill anything. It's just that it made a group called kill, and it looks like we're going to kill 4,000 of the 5,000, which, yeah, it's about right. So that's based off of these being zeros. So I'm going to put blast here immediately and say kill the kill group. So it's a little too aggressive right now. It's not really letting much live. So for one, I'm going to put the frame threshold super high just because I don't want it essentially to kill it by that yet. Everything's allowed to live as long as possible. Also, we'll let it, the size, well, I guess 0 is right. And so nothing will be smaller than the size 0. Everything will be allowed to live 520 frames, and nothing is slower than 0 speed. So basically we have everything We have the same exact sim. So let's start reducing stuff. I would say, let's start with speed. Most of these aren't moving. So the moment I start to increase this at all, they go away very fast, which is good. We don't want those to emit particles. We only want the fast-moving stuff to emit particles. And I really only want like the very fast-moving stuff. So we still have too many here. So I'm just going to move it all the way to 1. I mean, you can go higher than 1 also, but let's just start with 1. Okay, so let's take a moment to see what is even the highest P scale. I forget what we made it before, but we should be able to look at it now. 0.49, it looks like, on the X anyway. I don't even remember making this a vector, so that's kind of weird, but okay. So let's say, looks like around here we start losing everything. So I'm just gonna say, let's just keep like this. It's probably just comparing against the X value, but okay. So there we go. That's probably the only value that it's using anyway. So now we have a lot less, and it's the same thing though. We have a lot of pieces that live a long time. So I'm gonna say, you can live like a couple of frames. Oh, it's not really enough either. Let's give him a couple more frames. So there we go. So this is pretty good. So again, these are going to be the sources. So they live long enough to make streaks into the air, and then they disappear. And we also, again, have these densities recorded on here to say how many particles they should leave behind, as you can see. So great. So they're all ready to go. We're going to want to unpack these in order to actually have real surfaces, real actual political geometry to spawn from, because we don't want to just spawn from that. We'll want to transfer over the density attribute that we have here. Oh, that's transfer groups. So we'll want the density, we'll want the we'll want the velocity. And we probably don't really need anything else. So let's see what that looks like. So we've got here velocities, and then here, yeah, so there's their velocity per point. Here's their velocity per thing. You can see actually, you'd think that with the velocity just being one vector like that, that the unpacked ones would look like that. Houdini's trying to be clever here, and because these things have a spin to them, the angular velocity, which is of course W, it's trying to be clever and take that into account, and that's often good. I find that it ends up just complicating things. I like to have more control, so I'm actually going to delete the W out. So when you delete the W out of, well, that's the detail attributes, delete the W out of the point details, you'll see now it is just, so that's kind of a fun little gotcha, as you can see. And again, oftentimes you do want this, but this time I don't. And we'll add our own little like extra activity into there. Okay, great. So what else can we do? Let's do a time blend. We'll do that. We'll do that here actually first. Time blend will help us look at the subframes of this easier, which is important when doing particle simulations. So like if I go over here and I say turn off integer value frames and say, let's say we step by 0.1. Now when I scroll this, look at that. Look at that nice interpolation. So nice enough anyway. So that's what we want. We want this to have a smooth interpolation between frames, as long as the pieces exist. As the new pieces come online, they'll look a little weird, but that's pretty good. So go back to integer frames. Again, we have the unpack here. So that's what's going to be going on between frames that the particle simulation is going to be able to use. All right. So with all that done, We're only really ultimately going to need the density and the velocity. So that's the source.